So far we've been looking at writing lots of equations of lines given situations and 2 points and slope and intercept and slope and point. Well, now we're going to start looking at parallel and perpendicular lines. At the end of this lesson, you'll be able to write an equation of a line that's parallel to another line. All right, I'm first of all going to go ahead and just give a definition of a parallel line. Parallel lines have slopes that are the same. And I'm sure most of you are already familiar with slopes with parallel lines. They pretty much go right next to each other, but they never cross. Such as an example would be like a railroad track. The ties that are on the track, the two edges, the two rails would not touch each other. So an example, if I drew a graph, if I had a line that looked like that, one that would be parallel to it would look something like that, because they have the same steepness, so they're never going to end up touching. If I had equations, one equation might say y equals 3x minus 2, and then another equation might be y equals 3x plus 1. And if I'd look at that, if I went to graph it, the first one I'm going to start down at negative 2, and then from there I'm going to go up 3 over 1. Go ahead and connect them. And then the next one I'm going to start up 1, then I'm also going to go up 3 over 1. And notice when I graph them, they are parallel, they never touch, and I really, without graphing that, knew because they both had the same slope. All right, so would you please take a minute and write equations of two lines that are parallel? Alrighty, if I want equations of two lines that are parallel, I know that the m value must be the same. Okay, so I'm just going to just kind of like I did in that example before, if I could have y equals 2x minus 6, and then the second one, since it's parallel, it has to still have the 2x, and then it can say anything at once after that. It could be plus 3, minus 7, minus 10, plus 18. All of those would be parallel because they have that same slope. All right, so now let's use that information. This time we're going to be writing an equation of the line that passes through a given point, and it's parallel to the given line. All right, so this one passes through the point negative 1, 4, and it's parallel to y equals 5x minus 3. Now this is one of these that I'm going to start by graphing it just to show you what we're finding when we find it. You will not have to in your other examples actually graph this. So the point negative 1, 4 is to the left 1 and up 4, so I'm just going to put that point there. And then the line y equals 5x minus 3 starts down at negative 3, and then I go up 5 over 1. So it's going to look something like that. Okay, and what I'm doing, I'm looking for the equation of the line that passes through this point, but it has the same slope as the other line. So I'm looking for the equation of this line right here. So that's what I'm looking for. So let's go ahead and try to find it. All right, what I need to do with this, since this says y equals 5x minus 3, I need to also have y equals 5x because the slopes have to be the same. But then from here, I don't know what plus, minus, whatever. So I'm just going to put plus b because we really don't know what that's going to be yet. And now notice I do have an x and I do have a y. So we are all set to actually plug information in to help us find that b. So my y value is 4. My x value is negative 1. And then plus b. So I'm going to get 4 equals negative 5 plus b. To get b by itself, I will add 5 to both sides. So I'll get b equals 9. And then from here, I'm going to have y equals, again, I had 5x, and my b was 9. So, and you can kind of see how this it looks like it's heading for crossing the y-axis up at 9. So that looks about right. Okay, this next example, I have the equation goes through the point to negative 3, and it's parallel to y equals negative 2/3 x plus 7. So if it's going to be parallel, I know it also has to say y equals negative 2/3 x, but I don't know what it should go next to it. So again, I'm just going to put plus b, and then pretty much I'm ready to solve my problem. I'll label my x and my y, and just like we're used to, I'll go ahead and plug in that x and my y. My y is negative 3, and I have negative 2/3 times my x value is 2. Plus b. We're not going to be afraid of these fractions here, so I'll have negative 3. Negative 2/3 times 2 is negative 1 1/3 plus b. Now to get the b by itself, to get rid of minus 1 1/3, I'll do plus 1 1/3. Okay, and I should end up getting b equals 1 2/3. Right, so my final equation is going to be y equals negative 2/3 x plus 1 2/3. All right, let's try one more example. This time I'm going to let you try it, so if you would please pause the video and then come back when you're done and see how you did. All right, this one we are going to, again, since it's parallel to y equals negative 3x plus 4, I know my equation will say y equals negative 3x. I just don't know it's going to say plus what, so I'll put plus b, label my x and my y, and then 7 equals negative 3 times the x value, which is 5, plus b. So I'll have 7 equals negative 15 plus b. Then to get rid of negative 15, I'll do plus 15 to both sides, and that will give me b equals 22. So my final equation will be y equals negative 3x plus 22. Right? One thing that sometimes I like to do after I use this initial equation, I scribble it out so that I'm not tempted to use any information from it once I have pulled out the slope from it. So hopefully now you can write an equation of a line that's parallel to another line.